Everybody's people, good day all. Hey, I want to do a video about this other video that popped up about the Astra Zeneca that some European doctor lady made a video of. Well, apparently the fact check from Reuters came back that there is no aborted male fetus lung tissue in the vaccine. Um, they they allegedly discredit her. They're saying that they're using the 293 HEK cell line in the Chad, and it's not from lung tissue of a aborted fetus. It's from kidney tissue. Like big difference there, huh? And if you look to their actual fact check where they quote some paper that was put out in the journal Naturel, it's an unpublished paper, so they don't even have which means it's not peer reviewed or published, so anybody could write anything and not have it published. But then if you go down, if you read on, it says that it's not accurate to say MRC5 cells are the same cells from an aborted fetus. There are cell lines that have been grown in laboratory from a primary cell culture originally taken from a fetus. For MRC5 specifically, that was done on a male Caucasian fetus that was selectively aborted in 1960s. Here. There's another cell line, WI38, that was also propagated, aborted in the 60s. But what they're saying is, although that's where it comes from, because it's been filtered and processed so many times, that it's really not that cell anymore, which is true. It's genetically modified way beyond the statures of the cell, original cell itself. So let's look into the MRC5 on Wikipedia. We can find that the MRC comes from the September 1966, the 7th population doubling of the original strain. And the MRC5 themselves are known to reach senescence in around 45 population doublings. Well, what's senescence? That's interesting. All right, cellular senescence is a phenomenon characterized by the cessation of cell division. So we're talking about cell division, or replication. In their groundbreaking experience during the 1960s, Leonard Hayflick and Paul Moorhead found that human fetal fibroblasts in culture reach a maximum of approximately 50 cell population doubling before becoming senescent. This process is known as replicative senescence, or the Hayflick limit. The cellular senescence can be initiated by a wide variety of stress-inducing factors. These stress factors include both environmental and internal damaging events, abnormal cell growth, oxidative stress, autophagy factors, among many other things. This part's very interesting. Senescent cells contribute to aging phenotype, which is the characteristics of the animal or species in question, including fertility syndrome. What's fertility? It's a common geriatric syndrome that embodies an elevated risk of catastrophic declines in health and function among older adults. Fertility is a condition associated with aging and has been recognized for centuries. All right. Also, sarcopenia. Sarcopenia is a type of muscle loss that occurs with aging and or immobility. It is characterized by degenerative loss of skeletal muscle mass, quality, and strength. Oh, wow, that sounds really good. And aging-associated diseases. Senescent astrocytes are known collectively as astroglia, are characteristic star-shaped glial cells in the brain and spinal cord. They perform many functions, including biochemical support for endothelial cells that form the blood-brain barrier, provisions of nutrients to the nervous tissue and on. And microglia are a type of neuroglia located throughout the brain and spinal cord. Microglia account for 10 to 15% of all cells found in the brain. As a resident macrophage cells, they act as the first and main form of active immune defense in the central nervous system. So what it's saying is when we have this senescent, the doubling reaches a phenomenon of senescence in the astrocytes and the microglia. It contributes to neurodegeneration. Neurodegeneration is a progressive loss of structure or function of neurons, including death to neurons. Many neurodegenerative diseases, including amyotrophic lateral sclerosis, Parkinson's disease, Alzheimer's, fatal familial insomnia, and Huntington's disease. So that's great. And if we look to the Hayflick limit, it deliberates that the average cell will divide around 50 times before reaching a stage known as senescence. As the cell divides, the telomeres on the end of a linear chromosome get shorter. The telomeres will eventually no longer be present in the chromosome. This end stage is the concept that links the deterioration of telomeres to aging. So if we look at an X chromosome and imagine that just getting shorter, the branches on the X's are getting shorter and shorter until pretty much you have a round ball, which is what the alleged virus is supposed to look like anyway. So I thought that was very interesting. I wanted to share that with you. And these are effects of MRC5. Have a great day.